The next topic in this module is about rationalizing the denominator. The idea behind this topic is when you start getting into fractions that have radicals in the denominator, like for example 8 divided by square root of 2, you may not notice it, but that fraction is actually simply a multiple of square root of 2. So rationalizing the denominator is a way to simplify and remove the square roots from the denominator and put them in the numerator. So for example, on the 8 divided by root 2, the way to remove the square root from the denominator is to multiply top and bottom by root 2. Now that's not going to change the fraction because you're multiplying the same thing on top and bottom, but what's going to happen is on the bottom you'll come up with a root 2 times root 2, which the square root will take that pair of 2's and change it into a single 2 without a square root. On top, the 8 times root 2 just stays 8 root 2, but then the 8 and the 2 reduce, giving you 4. So altogether, 8 over root 2 is just 4 root 2. And we discovered that by using this trick called rationalizing the denominator. We multiplied by a certain radical to get rid of the root sign in the denominator. Right, to rationalize the denominator of a fraction means to eliminate any radicals from the denominator. So when you see the instructions rationalize the denominator, you should be thinking, I got to get these radicals out of the denominator. How do you get radicals out of the denominator? Well, to do that, multiply the top and the bottom of the fraction by the appropriate radical expression. Now, what you multiply by depends on what you're given. Okay? If you're given a denominator with only one radical, so something like 8 over root 2, then you multiply by that exact same radical. You take root 2 on top and bottom. But if you're given something that has a sum or difference of square roots in the denominator, like 8 divided by root 2 plus root 3, then you have to multiply the top and bottom by the conjugate. So root 2 minus root 3 in this case, and root 2 minus root 3. Right. So let's go ahead and try to put this strategy to practice, right? Looking at some examples. So on to our first example. The instructions say rationalize the denominator. In part A, we're given the fraction 18 over the square root of 6. So remember, rationalizing the denominator means to get rid of any radicals in the denominator. So for part A, we have to get rid of this root 6. Now you'll notice that there's only a single radical in the denominator here. To get rid of a single radical, the strategy is to multiply the top and bottom by that same radical expression. So I'm going to take 18 over root 6, and then to get rid of the root 6, I'm going to multiply the bottom by root 6, but then I also have to multiply the top so that the fraction stays equivalent. Altogether, on the bottom, this is going to give me the square root of 6 times 6 if you multiply underneath. But the square root takes that pair of factors and gives you back a single factor, which means on the bottom of my fraction, the square root 6 times square root 6 just becomes 6. On the top, 18 times root 6 is just that, 18 root 6. Now at this point, on top I have 18 times root 6, so I can reduce this 18 over 6. So let's see, 18 over 6 reduces to 3 over 1. So altogether here, my fraction is going to have a 3 root 6 on top, and then only a 1 on the bottom, so I don't even have to write that. So after we rationalize the denominator in part A, we end up with 3 root 6. For part B of this problem, we really have more of the same. Okay, the fraction has a single radical on the bottom, root 11. So what we're going to need to do to get rid of that is to multiply the top and bottom of the fraction by root 11. So we're going to take 3 root 2 over root 11, and to get rid of the square root 11, we're going to multiply the bottom by root 11. Then we also have to do it to the top. Let's see what happens here. On the bottom, this root 11 times root 11 gives me 2 factors of 11 underneath the square root. So the square root is going to take that pair of factors and give you a single factor back. So altogether on the bottom you just have 11 without the square root. On the top, to do 3 root 2 times root 11, you have to multiply underneath the square roots. So this is going to be 3 root 22. Now, the 3 and the 11 don't reduce, and also the square root of 22 does not simplify. Right? If you try to factor down 22, you won't find any pairs of factors in there. So there is nothing more we can do to simplify this, and the radical is out of the denominator. So this is our final answer. Okay, for part C, you have to recognize first that there actually is a radical in the denominator. The way part C is written, it looks like a single radical, but we know by our quotient rule that we can break this up into root 10 divided by root k. Right? You could take the square root of the top and the square root of the bottom when you have a fraction inside of the radical. Now at this point we once again have a single radical in the denominator. We have a root k. So to rationalize the denominator we have to get rid of this root k here. So I'm going to take root 10 over root k, and I'm going to multiply the bottom by root k to get rid of the square root, which means I also have to multiply the top by root k. Now on the bottom, root k times root k gives me 2 factors of k underneath the square root. So my square root is going to take that pair of factors and give me a single factor back outside of the square root. So root k times k is simply k. Then on top, root 10 times root k is root 10k. Now root 10k does not simplify. Alright, there's not a pair of factors in 10, there's not a pair of k's that I can get rid of. And since this k is trapped underneath the square root, this guy here is trapped under the square root, there is no way that I can simplify these 2 k's. One is under the square root and one is not. They do not reduce with each other. So ultimately here, I just end up with the square root of 10k over k. There's no more simplification I can do.